today's topic is instrument landing system. So when we are having this instrument landing system, there is an application of radar. By using the radar, we are having this application in our aircraft. So in this session, I am going to deal with the applications of various radar systems and the instrument landing system and its operation and how it works. It is the main concepts of this session. And in the previous session, I have told about what is a radar, what is the main principle of the radar, how it will works, and types of the radars. Under that, we are having three types. We have well known in the previous sessions, that is pulsar radar system, CW radar system, that is continuous wave radar system. Okay, and we are also seen with the moving target indicator system. Okay, the all of the three types are having different applications. Why? Because in the pulsar radar system, we are going to be seeing the range of the target. We are not going to seeing at the target image or height of the target, but we only sees with the range of the target, at which direction or at which distance it is going to be placed, that can be seen. And in the pulsar radar, we can't say it is a moving target or it is stationary. If it is the stationary target, it can be seen with the pulsar radars. And this drawback is going to be overcome with our CW radar. So that is, by passing the continuous wave signals, we are seeing with that moving target. That means in our CW radar, we can see whether the target is moving or stationary. If it is moving, either it is moving towards the antenna or it is passing away from the antenna. So that can be identified, that can be detected with our CW radar, that is continuous wave radar. So that is modified with the FWCW radar. So that is going to be using with the Doppler effect. Okay, it can be having the clear picture of our target. We can see with that particular target, what is that target can be seen with that modified CW radar. Okay, in that we are going to be using Doppler effect. So what is the Doppler effect? Means whenever the source oscillation and the observer oscillation is in a motion condition. So continuously it is in the motion condition, means the two are going to be moving conditions. So at that we are going to be getting some frequency changes, that is going to be calling as apparent frequency between the frequencies received. So that frequency is going to be calling as Doppler frequency. Okay, so that effect is going to be seen within the CW radars. Clear? So in the CW radars, what are the drawback? Means if we are having any clutter problems, what is a clutter? Means it is an unwanted echoes. Okay, so unwanted echoes means in our atmosphere, we are having number of things to be observed, that is fog, smoke, rain, cloudy. So like this we are having number of conditions we can observe in our atmosphere. So in that situations, the clutter is nothing but and the signals when we are transmitting from the radar, that is going to be having reflected to that particular conditions also. So from that conditions we are going to be reflecting back some echo signals. Okay, so that signals are going to be maintaining some disturbances or any errors in our radar systems. So it is getting some errors in our radar systems. So for that reasons, we are going to be overcoming with moving target radar, moving target indicator radar. So that is going to be shortcutly we are going to be calling as MTI radar, moving target indicator radar. Okay, so moving target indicator means the name suggests that it is nothing but which will be indicating that it is a moving target, and it is going to be used to find out the it is a moving target. And the moving target, it is maintaining some frequency differences that is calling as Doppler effect, and this can be overcome within this MTI. Okay, so this MTI radar, in that we are having a drawback. That means if the targets are more in our atmosphere, so if our observing number of targets, we can't get the clear picture of the target, so we can't identify that it is a particular stationary or moving target. That is the main drawback under the MTI. So based on our application base, we are using number of radars. Not only with these three, we are having number of radars to be used. Okay, so when we are having some applications of radars, the main application which is utilized in our aircraft, so we are having a different system. That system is going to be calling as instrument landing system. Okay, which will be used to pilot. So when we are having some pilot in the aircraft, he is going to be having some instructions with this instrument landing system. Why? Because whenever we drive a motor car, whenever we drive an bicycle or a bike, so we don't have any instructions given by the bike. So as our requirements, we are going to be driving that machines. Okay, so that vehicles are going to be driven by us, and that instructions only given by us only. But when we are having in the aeroplane, so in that we don't have any instructions of us. It will be having about around the atmosphere, what is that around the atmosphere, and how much longer from the earth curvature, so what is the weather report, so that can be seen within that system only, that can be notified by the instrument landing system. Okay, and not only with that, the instrument landing system is going to be giving them instructions to be landing towards the runway. So how it should be the land onto the runway, so how the distance is there from the runway when we are landing. Okay, so that can be seen with this landing system, instrument landing system. Okay, so in this session I am going to say the instrument landing system which is used on a runway. Okay, so not only with this, the first session is applications of radar. So radar, we are having different types of radars, and we are going to have number of applications. Each of the type is going to be used in a different manner. Okay, in the different applications. So like this, we are having number of applications. Basically it is classified as military applications, scientific applications, and civilian applications. Okay, so what is an military applications? Military applications is nothing but an used for searching and submarines, how the distance is there, where the position of submarines, so that can be seen with this radar system. And it is mainly used to control missiles. Military is nothing but our enemy will enter into our regions. Okay, so when it is not having the permission to enter the region, we are having number of missiles that can be forwarding towards our area. Okay, so like that, it is the radar which will control some missiles, at the same time weapons. Okay, so that is the main application of our radar. And not only with that, for bombing aircraft, so we can see in the movies, or we can see in our scientific researches, some missiles have some bombing techniques. So like that, in that also it can be used with the radar. And for ships, so larger ships, to have a location to be noted, what is the location for at a distance of some 2 or 3 kilometers from in the water. Okay, so in order to have that, it is mainly used. And to have an weather conditions also, the cities, what is the weather condition, that can be seen with our radar system. And it is also used for airport control. Okay, I have said that the main application of radar, it can be having in instrument landing system. That means it is nothing but an airport control. Okay, and it is used to provide early warning of enemy. So whenever the enemy is entering into our region, it is going to be notifying, it is warning that some enemy is going to be entering into our regions. Okay, these are military applications. That means it is used for searching for submarines, it is used for control the missiles, and it is used to control the weapons, and it is used for bombing aircraft, and it is used for ships, it is used for weather conditions in our cities. Okay, and not only with that, it is used to control the airport, and it is having some warning of enemy which is entering into our regions, and it is whenever it is having some control of the enemy aircrafts and ships also. Okay, these are military applications. And next one is scientific applications. So we are having scientific applications. There is a radar which is used to study the nature of stars and planets. Why? Because we are just imagine what is a star, how it will looks, and how it is the planet is going to be working. This it is an imaginary part. So how it is going to be saying this and planet, how it is going to be revolving, and how the distance from the earth is going to be maintaining, and what is a solar ellipse. So that all things can be done within a single device, that is radar, which is placed above our earth curvature. Okay, so that is the first application under the scientific application, and it is mainly used for tracking and guiding microwave spectrography. So what is a microwave spectrography means? Whenever we are using the satellite communications, in order to track that particular device, or in order to track the satellite, in order to guide that satellite, we are going to be using radar systems. Okay, these are scientific applications. And next one is civilian applications. Civilian applications is nothing but used for navigation purpose, and tracking spacecraft, and weather forecast using the radars. Sometimes we are having some warning system, that is cyclone warning systems, and the main purpose is to the police is going to be detecting the over speed drivers. Why? Because nowadays on the national highways, number of accidents are going to be done. So whenever the accident is going to be done, the police has given some instructions that on a highway it should be maintaining 60 speed whenever we drive some vehicles, or some vehicles is maintaining some 40 speed. So it is having some indications, some warnings boards on the national highways. So whenever the drivers are going to be maintaining, it is not maintaining, the speed drivers can be detected with our police with the help of radars. Okay, so that is the civilian application. So not only with that, it is also used for airborne altimeter. Okay, so these are civilian applications. Okay, so the first one is military applications, and the second one is scientific applications, and the third one is civilian applications. So the next topic is instrument landing system. So it is mainly used for safe landing of the aircraft when it is in the poor conditions, poor visible condition. Why? Because whenever it is having some rainy or fog, any smoke, it is very hard to land that particular aircraft. Okay, so that means it is mainly used for safe landing of the aircraft under poor visible conditions like rain, fog, snow, and in the night times also. Why? Because most probably the aeroplanes are having at the time of night. Why? Because it is very safe, and it is having some time duration is going to be very less. So like this we are maintaining at night also. So whenever it is having the night times, it is very dark to land the system. So for that reasons also, it is going to be using instrument landing system, and it is having great accuracy and reliability to use. Okay, the pilot must have a knowledge of safe landing of aircraft at correct position on the runway. Okay, and to maintain this, the instrument landing system, in this I have used the shortcut of this instrument landing system as ILS, which consisting of three parts, that is localizer, glide path equipment, that is calling as glide slope, or the next one is marker beacons. Okay, three parts. So what it does, so how it looks means, it is the figure to use this. So whenever the aeroplane passing from this, so whenever it is going to be landing, these markers are going to be indicating that you are crossing this marker and the next marker and the next marker. After passing the inner marker, it is to be landed safely on the runway. Okay, so this is an special device which is to be safe land of our aircraft. Okay, so the next is, what is a localizer? So what is a localizer means, which will be providing the horizontal guidance to the pilot about the position of aircraft, whether it is flying to the right or left or center of the runway. Just it will guide the pilot that the position of aircraft. That means whenever it is going to be landing on the runway, which will notify that you are flying to right or left or center onto the runway. Okay, this information is displayed on the display to the pilot, and it is located at 300 meters from the end of the runway. You can see this one. Okay, this is a localizer. Okay, so this is nothing but an 300 meters above from the aircraft. Okay, the information is going to be displayed on the display to the pilot. So on the aircraft, we are having number of systems to be controlled. So on that system, an instrument landing system is there, and that it is going to be displaying the pilot that you are in the center or you are in the right or you are in the left. Okay, so it is going to be located 300 meters from the end of the runway. Okay, and it is going to be operated at 108 to 112 hertz is going to be maintaining, and it has an antenna arrest. That means that these all things can be done within the antenna only. It has an antenna arrays providing carrier modulated by 90 hertz and 150 hertz signals. Nothing but an localizer is nothing but an antenna which is going to be operating it is not a single antenna, it is an antenna array type. Okay, so which will be providing a carrier modulated by 90 hertz, at the same time 150 hertz. Okay, so when the aircraft move right side of the runway, the 150 hertz signal is more stronger. That means how it will be notifying that it is a right side or it is a left side means, it is, I have said that a localizer is nothing but an antenna array which will be having a carrier modulated at 90 hertz and at the same time 150 hertz. So how it will notifying means, when the aircraft moves right side on the runway, the 150 hertz is going to be more stronger than the other signals. So that will notify that it is in a right side, and whenever it is moving at the left side on the runway, the 90 hertz signal is going to be stronger. Okay, like this it is going to be notified to the pilot. And when the aircraft move along the center line on the runway, these two signals are going to be cancelled with each other, and the zero position indicates. So it is not seeing any 150 hertz, it is not seeing any 90 hertz. Both signals are going to be cancelled as zero signals are going to be used. That means zero position is going to be indicated. That will indicate that we are in the safe position to land and it is in the center of the runway. Okay, this is the use of localizer. And the next one is glide path equipment. What is the use of this means, which will be notifying a vertical guidance to the aircraft when landing, and it is located at one side of the runway, and it is operated at 330 megahertz, and it has two antennas providing carrier modulated by 90 hertz and 50 hertz signals. And when the aircraft is flying above the glide path, the 90 hertz is going to be stronger, and when the aircraft flying below the glide path, it is maintaining that the 150 Hz signal is going to be stronger. Okay, in this we can see that it is in receiving antennas. Why? Because whenever it is having two antennas, we are maintaining as receiving antennas, and it will be providing carrier modulation only. These two antennas are going to be operated at 90 Hz, at the same time 150 Hz signals only. But whenever the aircraft is going to be flying above the glide path, the 90 Hz signal is going to be more stronger. So the pilot can see that I am flying above the glide path. Okay, so whenever the aircraft is flying below the glide path, the 150 Hz signal is going to be stronger. Okay, so like this we can see the height of the glide path, and we can observe the height of the glide path also. Okay, at which height is going to be there, you can see with this glide path equipment. Okay, so when the aircraft is flying along the glide path, two signals cancel with each other, and we will indicate as 0 position on the display, same as that of the localizer. But the localizer will say that it is whenever it is landing on the runway, which will notify that we are in the right side of the runway, or left side of the runway, or center of the runway. But the glide path equipment, what it shows means is vertical guidance. Vertical guidance means how much height is there whenever we are going to be landing. And above the glide path, if it is flying above the glide path, the 90 Hz signal is going to be stronger. But whenever below the glide path, it will shows that 150 Hz is more stronger with other signals. But whenever it is flowing along the glide path, the two signals are going to be cancelled with each other, and we will observe as 0 position on the display. So this is the glide path equipment. And the next one is marker beacons. So these are used to latitude, that is height checking, and provide the distance between the aircraft and runway touchdown point. The how much height is there to be touched to the ground of the runway. Okay, how much distance is there, how much height is there to land that particular aircraft to the runway point. Okay, so the information presented by the audio and visual methods also with this marker beacons, and which will be producing some fan shaped beams at right angles to the localizer. You can see within this these are the cone shaped, you can see with this. So it is a cone shaped marker beacons. So outer marker is going to be having a larger this. So the outer marker is having the longer height, okay, longer height when we are compared with the middle marker. So the middle marker is having middle, that is a normal height, and you can see with this, that is outer marker is having 4 to 7 miles of height, and at the same time middle marker is going to be having 3,500 feet. That means that when it is having some runway, the height at which, the distance at which we are going to be placing the markers, okay, and 1,000 feet from the runway point is going to be having the inner marker. So like this we are having 3 markers. By having this indication, it will be notifying as we are going to be reaching the runway. Okay, so you can see whenever we are traveling in the aeroplane, you can see that the aeroplane suddenly is not going to be run out onto the runway. Why? Because it is not only stops the runway. Why? Whenever it is reaching to the glide slope transmitter, that point to the C point, that is localizer, it will be running only. It is not stopping the aircraft. Okay, you can see very clearly when we travel in the aeroplane. Why? Because if it is touching to the runway also, the runway is not stopped still onto some onto the C point, that is localizer point. Okay, so that is the main intention of this instrument landing system. Okay, so that is ILS shortcutly. So this marker beacons we are going to be using only for the height checking. Okay, in order to what is the distance between the aircraft and runway touchdown point. Okay, and the information presented by the audio and visual methods are going to be there, and we are placing a fan shaped beams at the right angles to the localizers, and these is useful to pilot for safe landing of aircraft. These are the instrument landing system. Okay, after this clear, so let us have a quiz. So which of the following systems use a collection of radio transmitting stations to guide an aircraft to a particular runway? So please note this question, please. Which of the following systems use a collection of radio transmitting stations to guide an aircraft to a particular runway? So the first option is ILS, second option is GPS, and third one is VOR, and the fourth one is radar, that is RADAR, that is radar. Okay, so what is the system use of a collection of radio transmitting stations to guide an aircraft to a particular runway? Please note this question. So the answer is A, that is ILS, instrument landing system. So instrument landing system which will using a collection of radio transmitting stations to guide an aircraft to a particular runway. Why? Because I have already told that the ILS is going to be using an antenna arrays which will be maintaining a carrier modulation of 90 Hz at the same time 150 Hz of frequencies. So for that reasons only we are going to be calling as radio transmitting stations to guide an aircraft to a particular runway. Okay, this is the answer. And the next one is, how many ILS systems does an airport require? So when we are having the airport, so how much of the ILS systems are going to be used? The first option is 0, the second option is 1, and third option is depends upon aircraft size. And fourth option is depends upon density of traffic on the airspace. Okay, so these are the options. Please note this question. So, how many ILS systems does an airport require? Whether it is 0, 1, it will depends upon the aircraft size, or it will depends upon the density of the traffic which are on the airspace. Okay, so what is an answer? It is depending upon the density of traffic on the airspace. So how much of traffic is going to be willing to travel, and based on the traffic only we are having number of aircrafts. So based on the aircrafts we are having number of ILS systems. Okay, it is not a 0, it is not a 1, and it is not depends upon the aircraft size. Okay, so this is the answer. And the next one is dash standardize the signal in space for the ILS ground transmitting equipment. So dash standardize. So which standard is going to be standardizing the signal in space for the ILS ground transmitting equipment? So it is whether it is not clear, I think so. So dash standardize the signal in space for the ILS ground transmitting equipment, whether ISRO, that is ISRO, and the second one is FAA or ICAO standards and recommended practices, and the fourth one is NASA. Okay, that is NASA. So what is that option? So please note this question, please. So what is the standardize the signals in space for ILS ground transmitting equipment, whether it is ISRO or FAA or ICAO or NASA? The answer is C, that is ICAO standards, and it is having some recommended practices with the ILS systems. This is an answer. And next, so ICAO is nothing but the standards and recommended practice for the ILS, and it is subscribed by the 180 member states, and which will standardize the signal in space for ILS ground transmitting equipment. So no matter where they are manufactured, to maintain international standards. So that means if we are having any aircraft, you cannot use that aircraft in our space. So it should be having standardized with our ICAO. Okay, so and this ICAO is going to be subscribed by 180 member states. Okay, that is the main answer of this question. The next question: where is the localizer antenna placed? Whether the first option is beyond the stop end of the runway, or start of the runway, along the runway, or air traffic control. Where the localizer antenna placed is the question. Okay, please note this question. Where is the localizer antenna is going to be placed? Whether it is beyond the stop end of the runway, or start of the runway, along with the runway, or air traffic control. So what is an answer? A, that is beyond the stop end of the runway. So is not having end of the runway, it is the beyond that it is going to be placed. Why? Because it should be notified to our pilot that you are at the height from the runway, or you are going to be moving at the right side and left side along with the runway. Okay, that can be notified by the localizer only. So for that reasons we are going to be placing at the beyond the stop end of the runway. Okay, that is an answer. Next, which of the following is used to detect the failure in an ILS? If it is having any error or if it is having any failure in our ILS, what is going to be detected? Which of the following is used to detect the failure in an ILS? Okay, the first option is fail safe ILS, or radiation monitors, or ILS detector, or ILS failure system is not used anywhere. Okay, so please note this question. So which of the following is used to detect the failure in an ILS? Okay, what is an answer? That is B, radiation monitors. So by having the signals which are going to be displayed on the pilot display units, it will having radiation monitors. So it is not shows anything, so it is not having any radiation patterns on that particular display, so we don't have any detection, but it is nothing but an which will shows that it is a failure in an ILS. That means it will notify that it will shows that it is having some errors in our ILS. That is an answer. So the next question, what is the type of polarization is used in ILS system? What type of polarization is used in ILS system? Whether it is using the horizontal polarization or vertical polarization or circular polarization or no polarization. What type of polarization is going to be used? Please note this question. So, what is the type of polarization is used in ILS systems? Horizontal polarization, vertical polarization, circular polarization, or no polarization. So, what type is going to be used? For getting answer, what is that? Nothing but an horizontal polarization is going to be used. Horizontal polarization is used in our ILS systems. Okay. Next, so in this session I have told about the mainly ILS, that is instrument landing system. Okay, so in the previous videos also I have told the what is a radar and what is the principle of a radar, how it works, and what are the types of radars. Okay, so we are having all of these types, and in this session I have told about the different applications of our different radars. Not only single radar, a radar can be used in different ways. So I have told the 3 applications under this. So what are that means? It is a military applications and scientific applications and civilian applications. And in this session I have told about the instrument landing system. What is this? Is nothing but a major application of radar which is used in our aircrafts. Okay, what is the use of this? Means it is mainly used for safe landing of the aircraft. For what purpose? Whenever it is in the poor conditions to be land, that has rainy, at the same time fog, snow, and it is going to be a night times. Okay, so in order to get the greater accuracy and the reliability of safe landing of our aircraft, we are going to be using the instrument landing system. Okay, and the pilot is going to be very easy to understand to land that aircraft under these conditions, and the pilot should have a knowledge of safe landing of aircraft at correct position on the runway. And in this it is consisting of 3 parts, that is localizer, glide path equipment or marker beacons. So this is a figure which will be showing as a runway from C point to the outer markers. It is nothing but a runway to land our aircraft onto the runway. Okay, this is the button C. At the C point we are having a localizer, and internally we are having inner marker, middle marker, outer marker. Okay, so this is a runway, and from the C to some at a particular distance, that is 1000 feet of distance, we are having the glide slope transmitter also. Okay, so this is the figure which will be showing the instrument landing system, that is ILS. So what is the use of localizer? Means which will be providing the horizontal guidance to the pilot about the position of aircraft, whether it is flying to the right side or left side or center of the runway. This information is going to be displayed onto the display to the pilot. Okay, and it is mainly located at 300 meters from the end of the runway, and is operated at 108 to 1112 hertz of the frequency. And in this, what is the how it does means it consisting of antenna array type, and it is providing the carrier modulation by 90 hertz, at the same time 150 hertz of frequencies. So what it does means when the aircraft is going to be moving right side on the runway, which will be 150 hertz of signal is going to be stronger other than the 90 hertz. That means it really shows the aircraft is going to be moving right side of the runway, and whenever the aircraft move left side on the runway, which will be showing that the 90 hertz signal is going to be stronger. Okay, and whenever it is not showing any position, that means it is a 0 position, that will indicate that it is in the along the center line on the runway. Okay, so like this it is going to be used with the localizer, and glide path equipment is going to be used for vertical guidance to the aircraft when it is going to be landing. So when we are having the vertical guidance, which will be having 2 antennas which will providing the carrier modulation by 90 hertz and 150 hertz, but whenever the aircraft is flying above the glide path, which will be 90 hertz is going to be stronger, and whenever it is going to be below the glide path, the 150 hertz is going to be stronger, and only which will shows the height, at which height is going to be having in this. Okay, this is the glide path equipment. And the next one is marker beacons. So in order to land that aircraft, at which height is going to be providing the marker beacons. Okay, at which distance are going to be there of our aircraft. Okay, that can be seen with this marker beacons, and which is also having some audio, at the same time visual methods also, to have a clear cut of the height of the aircraft which is going to be used. And we are going to be using the fan shaped beams at right angles to the localizer to notify that it is having a shape, and we are having some lightings also for that marker beacons in our aircraft runways. Okay, and the main intention of this landing system is going to be used for very safe to land our aircraft. This is about our instrument landing system. Okay, it is very clear. I have told about the different applications of radar, and I have told about the instrument landing system and it working. Okay, thank you.